Alex is very passionate about developer testing tools, and he's going to talk about what testing means for Google Cloud Platform today. Alex?
Yeah, hi, thank you very much, Sonal. My name's Alex. I've been at Google for 6 years. Before that, I worked at some startups, some interesting places like Geico. Google's a lot more fun. I've been, for the last 5 years, working on our developer tools. I was the tech lead for a system that captures all of the build and test results from almost everything we run at Google, which you can imagine we do interesting things with that. Then I spent a couple of years as the tech lead for our continuous build system, which, again, covers almost all of Google. And most recently, I've been working on some new stuff, which I want to talk about today. I'm really excited to get sort of out of the closed wall of being inside of Google and talk to all of you about this stuff. This is a really cool opportunity. And I don't even know where my clicker is. OK, now I'm ready. But I'm not clicking the slide yet. So what I'm going to talk about is a little bit different from everything else we've heard. We've heard a lot of great stuff about how to write tests that are robust and that catch bugs, and how to execute those tests in lots of environments. I want to talk about what happens next. In particular, what do we do with all of those test results? And what do we do about failures? So it so happens that since Google has, I don't know how many thousands of people, so there's enough people that a few of us can work specifically on what do you do with test results. So I hope this is interesting for you. And I'm sorry that the slide title is not the same thing that's on your badge. So if you're here because of the thing that's on the badge, then feel free to do something else. I still think it's a good talk. Yeah, that was that slide. So my team works on basically continuous delivery. That's kind of the theme of what we're working on. We want to frequently release working software. We feel like this is an achievable goal. Ankit talked about pushing every hour, or at least cutting a release every hour, pushing daily, and not breaking things. So we feel like we're an important part of that. I know that all of you believe in that. And I think that part of having a good testing culture and getting your engineers really bought into doing testing is to sell them on this idea that this is part of their passion, right? And that it benefits engineers as well as the project that they're working on. So this isn't something like a manager has to insist that you should do. I think most engineers kind of have this impulse to get stuff out the door. But it's a hard problem. There's a few reasons it's a hard problem. They're all valid. For example, you need a lot of resources to run your tests a lot. I think there was a good question about, at Facebook, how do you get the resources to run all these tests all the time? At Google, we use every day 60 we use 60 CPU years of execution, CPUs every day, to run about 100 million tests. And I don't know if that's a lot because I've lost track of scale after working at Google for this long. You can let me know if it probably sounds like a lot. It's got 1 million in it. That's not what I'm going to talk about. Sure, get enough machines. You can use Google Cloud Platform or Amazon, get more machines. It's also hard to write tests that are reliable and that catch real defects and that run quickly. A lot of talks about that. Interesting, hard problem. I think, in my view, some of the best engineers on your team should be working on that stuff. I think the test automation is really where a lot of the challenge is in making a product that can reliably ship. So you need to get people excited about that. Also, I'm not going to talk about that, other than I just did. So what I want to talk about is the people problem, right? How do we motivate engineers to really buy into doing this? Imagine that you've got 15 minutes left. You have to go home for the day. I've got a 3-month-old baby, so I've got a pretty hard cutoff. So you have an interesting feature you've been working on all day. You really just want to send an email to your team and be like, wow, look, I stood up a demo server locally on my laptop or on my desktop machine since I'm about to pack up my laptop for the day. And I really want you to come see this cool thing I finished. It's so close. And then there's a build breakage. And I'm like, OK, so do I want to go fix the build right now? The build breakage is a bummer. That's not what I'm excited about working on. So how do you take that feeling about the you just don't feel like testing is the way you want to spend your time? How do you, especially in a typical company today, or at least a company like Google, like a lot of startups, engineers have a lot of leeway to make their own decisions. This is not, we're not working at NASA Ames and we have to verify that the space shuttle is going to launch and it's going to work, and it's really hard to ship live updates to the space shuttle. We're not going to watch the logs and be like, wait, we got to roll that back. We totally think we can just roll whatever it is back. And we think that we have the leeway to decide whether to write tests or not. And in a lot of companies, it's really the engineer is the person you need to convince, right? It's not the manager who's going to make the decision to write more tests. And I've certainly been frustrated when I have trouble convincing engineers about the value of testing. And I'm sure a lot of you at your companies, maybe you are the equivalent of Google's SET. I guess it's an SDET at Microsoft. And you have to spend a lot of your time just being the advocate for testing, and it feels a little bit like you're telling people to eat more healthy. It's like, yeah, well, they want to do testing. Like, they know it's good for them. But they really don't want you to tell them that. And they really don't want you to like block their code review and be like, well, you didn't put tests in there. So how do we convince them, right? How do we line up the incentives for an engineer? So they want to write the next feature. Here are 2 quotes from real engineers that I made up. I don't want to be distracted by bug reports in the last release. I'm going to read the slide to you. I know you're not supposed to do that. I wish those problems had been found by the testers. So this is somebody who's like, oh, like I wish this wasn't my job. Like, it's annoying. The last release, I'm totally over that. I don't even remember how to find that branch again. And then, oh, my quote mark moved. I'm sorry. That says I don't want to waste time on broken tests. If the build has been broken for a couple of days, I just ignore it. So how do we balance these 2 things? These are contradicting, right? So we're pretty sure that if you don't want to have to be distracted by bug reports in the last release, you need to know that the last release worked. How can you be sure that the last release worked if you didn't write tests for it? And I think there's been a little bit of discussion of, well, if you leave testers on their own, if you leave developers on their own, you don't give them a safety net, they don't have somebody writing the test for them, then they're going to naturally realize that they're going to have bugs in their next release. They're going to feel like they have to do some kind of testing. And ultimately, they want to have, we need to make this argument to them that sustainable velocity comes from having a healthy code base and having tests that tell you that things are working every time you commit. But a lot of engineers don't do it. They think it's like a waste of time. And a lot of startups don't do it because they're in a hurry, and it's a waste of time. So is it a waste of time? Like, how do you answer that question? Does it really increase or decrease the long-term velocity of this engineering team? In some cases, it actually, it is a waste of time. If you're writing some prototype code and you're pretty sure you're going to, only one feature in 10 is really going to launch to production, it is a waste of time to write tests for code you're not going to keep. There are some other cases where it's a waste of time to write automated tests for, a feature that's going to get turned down in 2 releases because it's just for, converting people from the old thing to the new thing. You may as well just manually test it for 2 releases. But I want to talk about the kind of testing that we're used to, right? We put tests in the code base. We expect them to stay there. We expect them to catch defects. And all of these things contribute to adding more test maintenance and giving people the sense that they're wasting time with testing. I think we should take these costs very seriously. So starting at the top, and Ankit said in his keynote that we have to weigh off the costs versus the benefits of having tests. And so in fact, their team tries to have fewer integration tests because they cost more. So if we can reduce the cost, then we could afford more integration tests, given the same amount of effort. So let's say you write a new testing tool, a lot of you have, and the user has to learn how to use that tool. They have to learn what the failures mean. Your error strings don't make sense to them until they've had that error a few times. And the worst thing for them is that there's a bug in your tool and the test failed and it wasn't their fault and they have to go track it down in your tool. End-to-end tests, we've talked a lot about at the conference. They're really great at catching real defects that you wouldn't catch with unit tests, but when one of those things fails, it's basically an exercise that's like debugging your production system. You have all the same parts running, you have to go look through the log files. There's probably the failure message is just I got a 500 and I don't know why. When the fixture is complicated, in other words, getting the system under test up and running, they're very brittle. They can be broken in a lot of ways. So we have security comes and says, oh, well, you can't actually make a connection from that place where your test is running to this other place where your server is running. That's not cool. Or you push some new configuration to you build some new configuration in your code, and then you discover, oh, well, when I bring it up in the tests, I need to have some different configuration to make it come up in the tests. You move servers around, things like that. The text logs, I will talk more about later, but yeah, I mean, we've all had to scroll to the bottom of a huge text file. And flaky tests, flakiness. So I'm also going to talk more about that later. And certainly, we've talked about that too. What do we do? Do we delete those tests? Do we try to fix them? So So these are kind of a lot of costs for doing testing. You don't have to do these things if you don't do tests. And the last one up there was the growing code base. So this is a picture from Jenkins. So if you hook up Jenkins to find the XML files after each run, then it will count the number of test cases. You can get this pretty graph. It's kind of nice for motivating people. You see this graph, you're like, oh, I'm so proud of my 1,000 tests. Like, oh, now I have 2,000 tests. I love my tests. They're so cute. Look at them. They're right in there. But then, like, this is sort of monotonically increasing. And that's fine. Like, this is a healthy project. But the burden of keeping all these tests passing means that, like, you know, once you're up to 2,000 tests, maybe you have, maybe not twice the chance, but much more chance of something failing than you did when you had 1,000 tests. And you know, parts of this code base you're not even actively maintaining anymore. These are tests that you just have in place because you're hoping that the legacy thing keeps working. You know, obviously there is a tendency sometimes to delete some tests, and then now you're scared to change that production code because you're not sure whether all your defects there are covered. OK, so I'm going to digress for a minute. To try and like figure out what do we need to do here for this problem of the test being too expensive. And in particular, testing is needed to keep engineers productive, but it makes them less productive. So how do we solve that problem? I think static analysis is a good example here. And I actually had the great the great opportunity to work with Bill Pugh, who wrote Find Bugs. He was a professor at the University of Maryland. And I just happened to work on a team where he was reporting to or he was sort of being brought in by the guy I worked for. So I got to sit down with Bill and learn sort of about what Find Bugs does. And we were running it at Google, and I kind of became involved in this project. And we even got to the point of integrating with the build system. So you could just say, you know, analyze my code. And then we built it into the code review tool. So it would say, hey, I found these problems in your code. Are they real problems? Well, we did this fix it. And you can go find a paper that Bill and I think one of his other students co-wrote. Called the Google Find Bugs Fix It. A Fix It at Google is where we go back and you know, spend some time to clean up some problem that somebody's identified. So in this case, it was, can we go fix all the real issues in our code that Find Bugs is finding? And we discovered that, yeah, these are real bugs. 77% of the issues that it found were marked manually by an engineer as either should fix or must fix, which are the classifications of, yeah, that's definitely a bug. It turns out that when the fix-it was done, we still introduced these things in the code base. So like, why does static analysis not work? And people have to think of this. People who work in static analysis have the same frustration people who work in testing do. Come on, like, I found real bugs, and I showed them to you. Why was that not enough? Why did you not fix them? Why do you not take this seriously? Like, why do you not eat healthy? But no, it's not enough. No, you didn't do enough. You showed them all kinds of real bugs. It didn't work. So how do you make it work? Well, what we did is we owned more of the problem, I would say. We said, OK, our job here is not to find bugs, although that is important. That's, you know, you can't do this static analysis without the static analysis tool. But like, what do we need to do to drive you to fix them? So we built static analysis into the tool chain. That means the Java compiler and Clang. And then we made those things produce fixes. So we can say, hey, like, I found this problem. It should probably have been this. Fixes sounds cute, like, yeah, people want to like click yes to their compiler a bunch of times. But actually what we did with the fixes is we built enough infrastructure so that we could go across Google's whole code base and apply the fixes, which meant that we were now free of this bug pattern and we could enforce it in the compiler. It could never happen again. So it's ratcheting it up. Every time we go through this iteration, we have one more little fine-grained bug check that you can never do that again in the code base. That's the case for errors, at least. For warnings, we can't stop them from being introduced. So instead, we were very careful in code reviews to only show things that you're likely to need to look at right now. And we have a feedback loop where you can click either please fix or not useful. And we use those clicks to determine which checks are valuable or not, file bugs against people who write the checks, and take a lot of ownership of this problem, right? So this turned out to work really well. So in August, our numbers were 255 Java bugs a day, and 71 in the code reviews. And we found that 74% of the bugs that we marked in compilation and 95% of the bugs we marked in code reviews got positive feedback from people. So we did a round trip to see if these were important. Can't give you any absolute numbers on the size of Google's code base or the number of bugs. I should also add that ErrorProne is my 20% project, so go use that. Quick plug since I'm up here and you all have to listen. So I think this problem is largely solved. Like we actually have way fewer of these bugs getting in now. And for the ones that we've made errors, we have 0 of them getting in. So what do I think is the lesson from static analysis? It's that we should think less like just it's our job to show people test failures, and more like if this was a product and the thing we wanted users to do was like, we could treat it like conversions, like you would do for a marketing website. Like we want people to go from we reported that there was an issue to they fixed the issue and the build went green again quickly. It's not good if there are other outcomes, like they decided to suppress this test, or they never fixed the build and it became a broken window, or like more and more build breaks piled up. So I think this is really our goal: is keep the build green with less maintenance work. And this is how we should measure success, to the extent that success measurement is a big deal at Google. We try to gather stats about whether what we're doing is working. So if we're going to gather a stat, it should not be we broke the build a lot. Didn't we do a good job testing? We found all kinds of defects. It doesn't count if they don't get fixed. What can you do about this? Like, I'm not suggesting that you should all build an infrastructure to capture these stats. But there are certainly some simple things you can do. You can make sure that when you write a test and you have an assertion and the assertion fails, it prints out a message that's clear about what's going wrong. If you're writing a testing tool, you can make sure that you're propagating whatever the user needs, like a stack trace that has the right things on the stack, that explains like where they can go to find more information. Maybe you can put up a wiki page that says like, oh, well, if this thing fails, here's what you need to do about it. It's essentially treating it like every time something fails, and it's hard for somebody to fix, it's kind of like a postmortem, like what could we do to make that simpler to fix next time? But we've been doing more than that, and I'm excited to talk about it. So there's this word breakage up here. That's like a super big deal. I'm really excited about this slide. Sorry, I didn't act excited enough. Yay! It's a big deal because sometimes to solve a problem, you just need to model things correctly, and then by modeling it correctly, a lot of the right solution just drops out. And so a breakage is what the user cares about. The user, in this case, being somebody who's like got a test failure, basically. Because yeah, you have users running tests, and if they pass, they don't care. Maybe they didn't even know the tests were being run because you've hooked it up nicely. A breakage is not a single failure of a test. So a test might fail 8 times in a row. That's one breakage. It might be more than one test. It might be that 5 different tests broke, but they all have the same root cause. Not that it's easy to determine that they all have the root cause. But that should be one breakage, logically. A breakage might be that you have several different builds, and they all depend on the same library, and somebody like revved the version of that library and broke all of those builds. That's still one breakage. And it might be that you're just running locally, and you've made some code changes, and now the tests are failing. They weren't before. That's still a breakage. And the interesting thing about a breakage is that it has a culprit. So really, your job as somebody with a broken test is to be like, what happened? Like, can I roll somebody's change back? Another common culprit is that the environment was broken. Like, the server wasn't running that you actually connect to from your tests, and so like the test is just getting connection dropped. And there's a life cycle to a breakage. And what we've done is try to manage that life cycle really carefully to drive somebody through to number 4. So first of all, do we need a human to be involved in this breakage? Let's try not to interrupt anybody at all. Taking an interrupt for a broken test is annoying. If we want our users to be happy, then like we should only bother them when we really need them to fix something. And then if we're going to bother somebody, let's try to find the right person. And let's also try and like let everybody else know that we've picked this person. So like whatever communication, somebody's like, hey, that broke me too, or I synced to my client and like I synced locally and the code doesn't build anymore. Whose fault is it? Try and get all that thread in one place. OK, so now we've got this person, and we've brought them somewhere to see a giant log file, maybe. Let's do more to try and explain what the problem is to them and some likely causes. So we could list like, oh, well, like there's some changes recently. Did you know this test uses this server, and the server hasn't been up lately? And then finally, gather the success metric. So did they resolve the breakage quickly? Oops. The other green button, right? Everybody else did that too. It's easy to go back twice. So flakiness. I'm so excited to have my chance to stand up here and talk about flakiness. Flaky tests are not that bad. They're not that bad. there's a scale, right? So like I've definitely been super annoyed at flaky tests and gone and fixed them. I've also had tests that are a little bit flaky, and I deal with it. I think that flaky tests do catch real defects that none of your other tests catch because the large integration tests that make sure that everything really, really works end to end are the flakiest. But the problem is that a failure of a flaky test is not necessarily a breakage. It's a really very noisy signal. And so if we want to get a useful signal from flaky tests, we need to do a little bit of a very simple signal processing on it. We need to look over a little sliding window of time at the pass-fail ratio of this test, and it can have one of three states. It's totally passing, it's flaky, it's totally broken. So if the transition from 0 to non-zero occurs, that is a breakage. The test went from not flaky to flaky. We probably want to do something about that. And the other transition from a non-zero ratio to 1 is also a breakage. That means this test is now failing. It's telling you something. Here's the signal you wanted, is that while this test is flaky and annoying, we didn't bother you about it until we were pretty sure that you actually need to go do something about it. It's pointing out a real defect. So there are a lot of things we do here. So this is just sort of a mock-up of something that could exist. Hint, hint. So it matches a known flake. Maybe we can look at the stack trace and be like, oh, yeah, we've seen large test.go at line 4. That fails all the time. So we can give you some hints here to try and explain that, like, what's the action you should take? Nothing. You didn't break it. Don't look at it. We don't alert the user for this one. This is assuming that, it's just, the success ratio hasn't changed. Let's say that there is really something broken. We need to get your attention. So yeah, we need to alert you somehow. We need to have a call to action that gets the user to come look at the problem. And this is something that we're all familiar with, getting an email from the continuous build system that says it's broken, but I want to point out that you should only get one email for this breakage. It shouldn't be that every time the build runs, it keeps emailing you over and over again. And then what can we do to help you? So at this point, we've picked an assignee, and we say, OK, we haven't identified the culprit yet, but there's 5 possible culprits. Probably it's 5 different commits that came in, but like I said, maybe a server being down is one of the possible culprits. We say it's probably not a result of flakiness, if we can figure that out. And importantly, we're coordinating here. So like, this is a page that everybody can see. If they're affected by this breakage, they should be able to come here. They should be like, oh, OK, cool. I see Vince is on it. That's good. We could even do clever things like, we look at the pull request that came in with one of the changes. And somebody made an after-the-fact note on there, hey, it looks like this broke something. So we should be able to do a really good job of helping you find what the culprits could be. And then at the end, we have the successful conclusion of the breakage. We see that the thing has gone green again. And now you can get back to work. And we want to get you through this flow really fast. OK. So this is a UI that you're probably all accustomed to. So this is a Jenkins build. Even if you don't use Jenkins, you probably have this many lines. This is not the whole log. This starts at line 2050. But the last line is the last line of the log. So step 1, scroll to the bottom. And then step 2 is, oh, well, it says here that there was a failure, blah, blah, blah. Go look at this file. But I happen to know, oh, well, this is Jenkins running Maven, so now I need to scroll up some. I scroll up a little while until I can find some more errors on the left-hand side. And that might suck, but hey, this is actually the best case scenario because maybe the failure is actually happening on the server that my test talks to, and so it's in the server log. So if it doesn't show up here, then I got to email the sysadmin and say, hey, can you let me log into the server because I think the error that's causing my test to fail is in the log file somewhere. So I would argue that even though it's possible to find a failure in a test log, that was not a good user experience. And that would make people less inclined to fix this breakage. So internally, at Google, we've managed to make a number of sort of micro formats that can express different things like, oh, this piece of infrastructure can sometimes fail. We have a way of dumping information about that. We have individual logs from different programs. So for example, each time we run the compiler, we grab its individual standard output, and we have that somewhere so that if the compilation breaks, we don't show you that giant log file. We show you the 4 lines from Java C that says the compilation failed. The problem is on line 15. So landing on that log file is not the desired course for the user to take through our application. Sorry, I reordered some slides at the last minute, so now I have to try and use the back button again. Come on, back button. I don't have the capability to reload. Oh, it's going back. Now let's see if I can find the right place to go back to. Yes. OK, so now we've drilled down into the sort of, there was an investigate button on one of those pages that was supposed to help you, like, you know, OK, it's like you're the person we've picked. There's a real failure. You need to deal with it. What are we going to show you? So it's pretty cool if we can show you something to do with the root cause of the problem. So we can try to do delta analysis. In this case, like within this one log, we were able to pick out an assertion that failed and it had an expected but was. Maybe we can put those next to each other. We might be able to do the same thing with this failure and a previous pass of the same test. So a lot of the times, like 2,000 of those lines will be the same when it passes and then when it fails. Can we show you just the delta of the time when it failed? And it would be really cool if we can show you things like screenshots or videos. So yesterday we heard from Jay at App Purify, and we saw some of the awesome data that they're able to gather out of tests. We saw that again today with Spoon. It has a pretty cool model of like stuff that you can pick out of a test that helps you figure out which devices your test is failing on. And if we can combine that data with the context of the fact that this is a continuous build, or maybe you did a local build, but you're synced to a change at which the continuous build ran, we should be able to do some sort of delta against the state before and the state after. And that should really help us find the root cause of the breakage. So I'm hinting there that at the data model, and like a big text file, is that cool? Obviously, I think the answer is no. There it is again. So a test result, really, like logically, what's in there? It's a representation of everything that happened while the test was running that could help a user figure out what's wrong. Screenshots, constraints. So maybe this test is now consuming more memory than it did before, and so it no longer runs on this mobile device. Maybe you have in your build tool, you have a timeout. Like, can we tell that this test timed out instead of it just failed, and then you go dig in somewhere and you see that, oh, the build tool said that it timed out, but all I got back from it was fail. Can we figure out that there are points in the infrastructure that are flaky? So like ADB is flaky. Can we like report that as ADB flaked, not your test failed? And then can we do other things while the test is running? So can we gather the network analyses? We saw that from App Purify. Can we get other metrics that you might choose to publish? And can we get logs from all the machines involved? And can we correlate the timestamps on those logs? So can we say, like, oh, at about the time that the client had this problem, even though you were hitting a prod server, heaven forbid, and there were a lot of other requests coming into that server, we're able to sort of find, like, your request was one of these in this small range, and you can correlate that with the failure on the client. So that would all be really cool. I don't know how to do that with the tools we have today, as far as I know. XML, the XML that you get out of most of the xUnit tools doesn't represent any of those kinds of results, right? It can give you stack traces. It can give you a tree of test cases. I think there may be some way to get like the execution time in there, but there's no way to attach screenshots. The screenshots just get written to some directory on the disk where the test ran, and now you have to go find that place where the test ran. If you're running your test on cloud, then that machine could have been deprovisioned already. Like, now you have to do all this extra work to make sure you gather up all the screenshots that you wrote, and only you know the path where you wrote them to, because it's your job when you run WebDriver to tell it where to write the tests, where to write the screenshots. So it's really hard to gather all this stuff and bring it back. So like the giant text file is kind of the best thing we have today. I think we need a better way to gather all that information. I should point out that there are a couple of things, test anything protocol and subunit, which didn't really look like something we would, like, as an industry, want to build on top of. So yeah, are we going to do something about it? Yes, I hope so. So one thing we've done, I've got a URL there, which you're all probably starting to type. This is work in progress. This is not a finished product, please. This is like not an announcement of like you should all go code against this thing. But what I would like to get is some sort of format that we can mostly agree on that a lot of consumers and producers would write. What are consumers and producers? Well, you have a lot of tools like maybe you have your continuous build, and then you have your build tool, and then that calls your test runner, which then calls your test, which then uses some libraries. Those are all things that could potentially produce outputs that would be relevant to figuring out why it fails. And then The consumers is the UI you look at, but it could be something in your build tool that wants to decide whether it should retry or not. So it would be nice if it can tell that this was an ADB, failed to like initialize the remote device, as opposed to your test really failed. So is it a transient or permanent failure? Can it be retried? I think there's a lot of stuff that can be built once there is a format that at least a lot of producers and consumers are writing. How many are doing it now? 0. Well, I think we read the xUnit XML. So this is where I hope that we will make some progress in defining a format, and then eventually, maybe with some of your help, getting tools to start writing that format. So like I said, this is still at the beginning. I met with somebody who works on Protractor today, and we were like, oh, that's cool. Like, they're actually getting ready to start writing the XML files. Maybe we can start grabbing screenshots that you grab from WebDriver as part of Protractor. It's all in the future. The basic design is a file system, because that's convenient. Like, even if your test runner is a bash script, you can probably manage to like emit some lines to a file. Next to those files, we need some sort of metadata that annotates it and says the MIME type and the description and like maybe what UI you want to open it with. Not a lot of data. And then ideally, we want to be able to have multiple processes and multiple machines writing this stuff at the same time. So it has to be a format that allows you to have uncoordinated processes all writing to the same place. So you might need to have a distributed file system. Maybe Google Cloud Storage, maybe Amazon S3, maybe like a network file share within your company where the tests are running, that you can write all of this stuff. And it needs to be extensible, because none of us knows what tools need to write there, and there will be another tool tomorrow that we would like to be able to use the format. And it should be streaming. Like, we don't want somebody to have to wait until the entire process is done and we've torn down all of the remote machines where things are running before they can even see like, oh yeah, at like minute 1 out of 20, there was a failure from like the build tool, but I could have already been working on that. And obviously, it needs to be cross-platform. Like, we're not going to build this in such a way that you can only use it with Java, or you can only use it with Android tests. It needs to work for iOS and so on. The other thing we're working on is a service to do the sort of breakage lifecycle management that I talked about earlier. So this, again, like, we're not ready to announce it today. I hope we'll be ready to soon. So this is going to be something where, like, if you've written one of these file systems with stuff in it, you could hand it to us through an API, and we can figure out and help you like identify these breakages and manage the process. I hope we'll be able to announce that soon. So if you'd like to be an early user of that, once we're ready to sign people up, you can talk to me. I've also got my coworker Mo is back there in the green hoodie, blue hoodie. So we'd love to talk to you afterwards about signing up for that. So let me sum up a little bit. You should, I think the best way to get engineers excited about testing is to make it not suck for them, which means that you need to like not just own showing them a bunch of red boxes, but like getting a green box on the end of that sequence. And I think breakages is a nice concept for modeling that in your head and like making sure that you're thinking about the end of a breakage. And I think that we need more fidelity in the test result data. And it's lame that like the best thing we have right now is you just dump some stuff out to a machine that you may not be able to find later when you're investigating the failure. And of course, somebody might file a bug for a failure. It could be weeks later that somebody needs this particular screenshot. And I also hope that, since I don't have anything ready to announce to you today, that you can start thinking about what can you do in your test or your test framework to make it easier to track root causes of failures, and what can you do to like have a postmortem culture of when something breaks and it's really hard to figure out why. How can you make that better for somebody next time? Like, what was it about that breakage that made it so hard to fix? Yeah, and I hope we'll be able to work together. So that's all I have. Thank you.
Thank you very much, Alex. Some excellent thoughts over there. So any questions for Alex? Anything on the moderator link?
Good question. Where do you think you stop pleasing the engineer? I had the instance when developers will tell me, well, until you have a repro in the debugger break-in and the point, I'm not looking at it. Where do you think, how far do you go?
Sorry, the question was, at what point do you bother the engineer?
At the point you stop doing everything you can to get developer to look at the problem.
Oh, OK. When do you give up? So like if the build is broken and nobody's taking ownership of fixing it, like I've suggested that you pick an owner and you tell them to fix it. Maybe they reassign it around. It goes for days. It doesn't get fixed. That's definitely a problem with the testing culture in the team. I think the typical thing to do is to like suppress that test so you can get the build green again and move on. Some tests will probably die along the way. Obviously, the more important thing is that you continue to have your other tests running in green so that you don't have the broken window syndrome and somebody breaks another test and says, oh, well, the tests are broken anyway. I don't know if that answers your question. Feel free to clarify it.
We have a couple of questions from the moderator. So non-hermetic tests will appear to have been broken on a particular change that has no relationship to the root cause. Is the only solution to scour all tests for hermeticity?
Scouring tests for hermeticity. I'm trying to imagine how you would do that. I mean, there is a little bit of a yes to that. So we've been thinking about, we run all the tests in a remote execution environment where we could trace all the network calls they make. Maybe we could give you a report that says, hey, when your test runs, these are all of the external resources it talks to. It's not the only way you could have hermeticity problems. Like we saw earlier, you could have a race condition between the UI thread and the testing thread. Oh, speaking too quickly, it says. Oh, I wish I had seen that earlier. Maybe I would have used all my time. Thank you. So could you repeat the first half of the question again?
Non-hermetic tests will appear to have been broken on a particular change that has no relationship to the root cause. So what can we do about that?
So I think ideally the logical way to model that is that it's the same. If the test has been flaky and it continues to be flaky, that's not a breakage, and we should do things to make that test remain useful. So there's a spectrum here. There's a judgment call to make, right? So if it's incredibly flaky and you can never release because you have 10 of these things, and so like you'd have to have a really fantastic chance that like they all pass at the same time, that's obviously like those are not good flakes. You need to do something about it. If it's a little bit flaky, but it really gives a lot of value, and like if the test fails, yeah, I didn't learn anything. But when that test passes, man, that means that the whole thing worked. Like it's amazing. Like there's no way that test could possibly have passed unless everything was wired together just right. I think that's the valuable kind of test to have. Yeah. So yeah. I think flaky tests are kind of okay. Cool. But without the right way to like alert the user to what's really a breakage, like a transition, like I said, from passing to flaky or from flaking to failed, then it's very annoying to have them show up in front of developers all the time. So I hope that's a problem that we can fix.
Yep. And a different question, xUnit was originally designed for unit testing, presumably. Most rich test data results come from larger tests. Is it time to call into question the entire unit test model for large tests?
So the unit test model. So yeah, I mean, these large tests are not unit tests. Obviously, naming things is one of the two hard problems in computer science, along with concurrency and off-by-one errors. I think the model of unit testing is like you set up a fixture, which is your system under test, and then you exercise the fixture, and then you make assertions about the side effects that it had. That's all the right model. And I think these typical xUnit tools, yeah, they gather the right information for a typical unit test, and they don't do a great job of gathering all the information you need for larger tests, and so we should gather more information. I don't know that really changes the model.
So you mentioned that the breakage tool will tell you or tell the user or the developer that whether a test is flaky. How does the tool will work to detect flaky tests, and will it work with a new test?
No, it wouldn't work with the new test. So if we've never seen a test before and it fails, like yeah, there's no sliding window over which you can tell that it's a mix of green and red. We've tried a few different algorithms, and we've had a lot of different teams at Google trying to deal with flakiness. A simple one is just you look at the sequence of red and greens, and like if it's like one red sprinkled in there every now and then, that's probably flaky. So we can mark it, like we can look at the sequence of runs for a test, and if we see that, we'll tell the user, hey, that one's probably flaky. So at least even if you do see a red build and you come to our UI, then like you can quickly decide it's not your fault and leave. And I know that some people have a way to like manually mark a test as flaky. One cool thing we have is that if you do manually mark it as flaky, it gets retried by the build tool. which you could probably build into some of your testing frameworks, but you would have to have a way to know that this test had been marked flaky. Yeah.
So when it comes to making a new test format, right, the xUnit format is sort of just pass-fail. And it works for everything because everything has to pass or fail. But it seems like a generic format, a richer generic format would have to be compatible with like a whole lot of different types of artifacts, right? And aren't the artifacts going to be really specific to the type of testing I'm doing or something? Do you have any thoughts on like how flexible or generic a rich format needs to be?
Yes. So yeah, in our experience, and actually if you took the office tour, you might see above the toilet, there's an article right now about internally, how do you gather all the different kinds of outputs that can come out? It does need to be extensible, so we don't know right now what all the different tools will emit. I think there are a lot of things that are very common, or at least I hope we can model a great deal of similarity between tools. So things like screenshots and videos, you just associate the MIME type. Ideally, you associate them with the test case that passed or failed, but that will work in both an Android, iOS environment or a browser WebDriver environment. I think there's certainly, I'm taking kind of a risk to propose this format without having figured all these questions out. So yeah, there's obviously a risk that this doesn't succeed and we continue to have large text files. I hope that we can find a model that, let's say the 80% rule that covers 80% of the stuff with only 20% of the work.
Cool.
All right, thank you.
So, thank you, Alex.